Hello, welcome back. In this session, we will introduce how to use CNIX's soon-to-be-released digital twin with a simple example. These days, everyone is directly or indirectly using AI services. However, training and utilizing AI in a way that suits your needs is not always easy, and often the exact service you want doesn't even exist, especially in a specialized environment like a manufacturing site. A lightweight and personalized AI may be necessary. This is because AI models can quickly reflect ideas from on-site personnel for problem-solving and process improvement. Here, Pascal, Phoenix's digital twin system, is about to be launched. Pascal is the name of Phoenix's digital twin. If your dataset is relatively small, less than 1 million rows, Pascal allows you to train and analyze your data in real time, even without a GPU. Of course, a little bit of patience may be required. Additionally, the trained AI engine is very light and supports multiple TCP, an industrial standard communication protocol, so that you can use it with external HMI or viewer systems. This means you don't need an expensive 3D UI. You can leverage the AI inference results with the familiar HMI tools that are commonly used on site. Now, let's move on to how to use Pascal. The screen you are looking at now is the environment where I conduct tests in my lab. As you can see, the Pascal system is based on the server client module. And if you check the specifications of the Pascal server here, you will notice that it doesn't have a GPU. Of course, if it had a GPU, the AI's training speed could be dramatically accelerated. The Pascal system you are seeing now is set up by installing the Pascal server on a laptop I purchased about 10 years ago, making a system capable of training AI. Now let's check the results on the client. The server and client are connected via network, and the AI's input and inference data are handled through a modul's TCP interface. When the data set required for training AI is massive, a GPU is essential. However, the trained AI is very lightweight and can operate on a CPU without a GPU. Alright then, let's start by preparing the training dataset. The dataset you see is a portion of a text file that will be used for today's demo. The first line contains the data labels. The second line specifies the data types. And from the third line onward, the actual data appears. The dataset is divided into input data and output data, with each consisting of digital data input, analog data inputs, digital data outputs, and analog data outputs. By training the AI using this text file, it learns the relationship between inputs and outputs. Once the AI is trained in this way, it will infer and display the outputs when a user provides the input conditions. Now let's watch the demo video. The screen you see is the Pascal client. First, let's log into the Pascal server. Once you logged in, open the project prepared on the client and upload it to the Pascal server. As you can see, the uploaded project appears in the tree on the left. Next, when you edit and save the training parameters, the updated settings are transmitted to the Pascal server. Now, let's train the AI. Once you select the training dataset file, the training process begins. Before training starts, Pascal verifies that the dataset to be transmitted matches the provided training parameters information. After this check is complete, the actual training commences. As you can see on the screen, you can observe the AI training processes. Alright, training is now complete. If you have a test data set to verify the results, you can run tests as shown. Now, let's run the trained AI. When you execute the trained AI from the menu, you will see the digital twin in the run state in the left tree. Once the digital twin simulator is running properly, we will check the AI's performance using an HMI tool that supports the Modbus TCP interface. As you can see, you can view the AI's input results from the user's input in the HMI tool. Also, the digital twin's scan time is approximately 67 milliseconds. And if the Pascal server has a GPU installed, the execution speed becomes incredibly fast. However, if the AI's inference results are not connected to actual I/O, there's no reason for the speed to be that fast. As you saw in the demo video, the result inferred by the AI Pascal can be viewed on a standard HMI via Modbus TCP interface. Since the Modbus memory map is automatically configured by Pascal and provided as a text file, using the AI is not an issue as long as your HMI tools supports the Modbus TCP interface. What do you think? Isn't using AI easy? In the next video, we will showcase an example from an actual industrial site. Thank you for watching.